Hello there. Welcome to another tutorial of Plexus Lab. Today we're going to talk about function APIs or code blocks. Alright, so as we saw in the previous video, Introduction to Functions, this is the function page. And we have prepared a set of APIs or code blocks that you can use to either call, read variables, write variables, set timers, alarms, and so on. So we're going to go through each one of them to show what they do. All right, so starting from the general API, we have about 7 of them. So the first one is just an if read, which means it's going to compile for you a little piece of code, which is one of the most useful in Plexus Lab, which is if a condition is met, do something here, otherwise do something here. No much to say here. It's just a general structure on an if-else statement. So this is how it works. The second one, it's another simple if read write. So it says if a condition is met. So for example, we read a variable at a certain, let's say we read button 1 is equal to 1, write val blue equal to 1. And let's say otherwise we write blue equal to 0. If we save this, upload it, and activate it, if we press this button, the LED turn on. Okay. Then comments are just what you see up here. So if you put /, then everything becomes green and you can write any text that you want. And this will not be executed. So it's very useful to write it so you know what you're doing and you remember for later. So if you write comment title, it's just a pre-made little string to make a title just like that one. Or comment small is just a little comment here. If you want to write a block of comments, you can do /* and then */. Anything included within these lines is going to be comments. So again, nothing of this get executed, so you get no errors. Now, debug message we saw in the video before, but it's something very useful to write yourself messages during the code, so we know that this is executed or not. Just a message. Save and upload. Now this debug viewer become yellow when we click it. Here we got messages. So while you write functions inside your code, you can write messages to print if this piece of code is executed. Info message, we're not going to take a look at it right now. We'll see in the video for panels, since it's only connected to the HDMI panels. And device status, return 0 or 1, depending if our device is active or not, and it's running correctly. So for example, we want to say that we want to debug message that information. So device status is, and here, write device status, and then here we write the name of our device. Plexus pod C1. So if we save and upload it, we see that now the device status is 1. Everything is running smoothly. If I disconnect the Ethernet, for example, device status becomes 0. So that means if the cable breaks or there's any problem with the Plexus pod or problem with the communication, at least you get notified so you can do some actions if one of the pods is not responding or one of the devices is not responding, not necessarily a pod. Okay, now it's back to 1. And that's it for the general code blocks. Okay, now we talk about variables. These are the most important ones. You're going to use them all the time to write your logic. So let's start with the first one. So read val, it takes as an argument only the name of a variable. So the name of the variable could be a variable in section or a variable in devices. So in our case, to just show how it works, we're going to do an if statement. So let's say that in sections, we create a couple of variables and we call it v1, and then we call it v2. So in going back to functions, if we say, for example, if v1 it's more than 10, we write value v2 at 10, otherwise we write it to 0. Okay, very low simple function to show you that readVal returns the actual value of whatever variable name you're putting in there. So if we're going back to sections and we put v1 to 15, which is more than 10, we see that v2 becomes 10, put it to 9, it goes back to 0. All right, so for read future val and read average val, in order to use these ones, you need to be recording some charts. So go to see the chart video to see how this two works. So for now, we're going to skip them. So for write val, we already saw it. The way it works is that we insert write val and then the name of the variable and the value that we want to give to that variable. So name, comma, and then the value. Write val delay, it pretty much writes a variable after a certain delay. So if we put write val delay and we put our v2 in here, we say, okay, we want it to be at value 10 after, let's say, 2 seconds. Here is the value in milliseconds. So name, value, and then how many milliseconds after you want that value to be assigned. Now, we need to immediately look at reset val delay. So once that gets set with a certain delay, we need to reset it somewhere in order for that delay to be active again. So here we do reset val delay, and we're just going to give v2. So the way this is going to work is that once we set this value to more than 10, it's going to wait 2 seconds and then set this to 10. And then if we go lower than that, we're going to reset that delay and then write the value to 0. So if we go into functions and sections, let's see that. So let's say we write 15, 1, 2, and then becomes 10. Now if we go back to 0, that goes immediately to 0 because we have no delay. If we do it again, we'll still have 2 seconds delay, and then becomes 10. All right, now write val period. This one writes a value. I'll show you an example. Still use v2. So we can toggle between 2 values in a loop constantly. So the way we want to do this, let's say we want this v2 to go from value 5 to value 10, and we want to say that stays at 5 for 1000 milliseconds, and then stays at value 10 for 2000 milliseconds. So if we do that, we can also remove this one. Okay, so just for the structure, so we have first the name of the variable, first value, second value, how many milliseconds stays at the first value, how many milliseconds stays at the second value, and this will loop constantly. So if we go back to sections, we see already circulating between 10 and 5, it says 5 for only 1 second and 10 for 2 seconds. And this will be continuing forever until we go lower than 10, and that becomes 0. The other interesting one, it's write value in a ramp. So let's say we want to make sure that whenever this is more than 10, we write this variable from 0 to 100 in 10 seconds. But we want a smooth transition between 0 and 100. So we say ramp value start, we say from 0 to 100 in 10,000 milliseconds, the variable v2. Now, it's the same thing as with the delay. We need to reset this ramp if we want it to start from the beginning again. So in the case the condition of 10 is not more than 10 is not met anymore, we're going to reset value ramp for v2 and save it. So this function there is going to work. Let's go to 11, for example. It will start transitioning from 0 to 100 in 10 seconds with all the values in between. Once it reaches 10 seconds, it stays at that maximum value and we stay fixed there until we reset that. So if we go back to 9, for example, that will go to 0, reset the ramp, and when we go back to 11, it will start again. Okay, so last one, write value at time. So write value at time will set again a certain variable at a certain value that we want, let's say 10, at a specific time. So during the day, for example, if we want to turn on, let's say, an irrigation system at 10 p.m., at 8 p.m., we'll just write that. And then let's say we want to turn off that same irrigation system. All right, let's say 1 to turn on a valve, and then 0 at 8:20. Considering this is met, so if v1 is more than 10, at 8 p.m. this variable will become 1, and then after 8:20 it will become 0. And if we want to do at a time range, so we want to set a variable for a specific time range, we just write variable time range, and again, name of the variable, the value, and then here between 4:20 and 4:30 p.m. Okay, now timers. Timers are definitely crucial in any automation system. So we created a little set of code blocks that can help you manage time-sensitive situations. So let's say that if our variable v1 it's more than 10, we want to set the variable v2 at a certain value after 10 seconds. Now we can do it with the write val delay, but just in case we want to do a series of operations after a certain amount of time, then we'll do something like start timer, and the timer name will be red timer. We have a timer set in the sections. Now, as soon as the code will go through here, it will start a timer. Now, we can check if that timer is running by putting timer running, this function right here. So if timer running, and then we give the name of the timer, we'll do nothing. If it's not running, then we want to write our variable v2 at value 10. And otherwise, if v1 is less than 10, we're just going to write our variable v2 at 0. Okay, so if we go back to sections, if we see if we put v1 more than 10, this time it will run, and as soon as we arrive at 3 seconds, this value will become 10. Now if we go back to 0, this will be set to 0. One thing to remember is that once a time started, it will run until it stops, and then when it stops, it will need to be reset in order to start again. So in our case right here, if we set this less than 10 and put this one will be set to 0. As soon as we're going to put it more than 10, if the timer is already done, it will go into this section of the code because the timer, it's already been exhausted. Now, if we want to reset the timer, we're going to use just the reset timer function here. We'll put the name of the timer. Save and upload it. So once we go back here and we go more than 10, the timer will start. It will be running. Once it's done, we see that this is black, so that means the timer, it's not being reset yet. If we go to 0, so less than 10, the timer is automatically reset. So next time it can start again. We can also, so we can start the timer, reset the timer, pause it. So at a certain point while it's running, we want to pause it for some reason, we can just put pause timer and then pause that timer. And if we put 1, it will pause it. If we put 0, it will restart it. Timer running returns the fact that the timer is running or not. Retimer gives us the value of that timer in milliseconds. So for example here, while it's running, we want to display that value. We can come here, so it's like value timer. And in the function, while it's running, we're going to write the value of value timer as read timer timer. Okay, so now if we go back here, obviously it's in milliseconds, so the maximum here should be much higher, 10,000. Let's go back to 0. And 1. All right, so this is the value in milliseconds of that timer that it's been assigned to this variable. All right. The last function is set timer duration. So as you can see in sections, you can set the timer duration directly from here. So we can change the value of the timer anytime, for example, to 10 seconds just by inputting the value 5 seconds, let's say, and then pressing enter. That will be set. So next time that we want to start that, it will actually go up to 5 seconds before activating this V2. But if we want to set it directly from here, we just write it anywhere. So let's say set timer duration, right timer, and the duration in milliseconds. So let's say 4,000 in this case. Save and upload it. So as you can see, already changed its duration to 4 seconds. Now, even if we try to change it via UI, this will not be able to because the function is winning and it's changing our value back to 4 seconds. All right, so now we talk about alarms. There's just a few functions here, functions block. So we can set an alarm if there's anything happening. For example, any event you want to send an alarm out, you can set it by simply writing set alarm. Now we need to put the alarm name, so let's create a couple of alarms here. Test alarm. So set alarm, test alarm, and here we can write a message. So now it's not mandatory, you can remove that if you want to, but this will be recorded every time an alarm happens. So for example, we say this value is more than 10. Okay, and then we can also reset an alarm. We can do it manually from here. So if an alarm get activated, then we can reset it manually, or we can reset it automatically by a function. So right here, let's say if it's less than 10, we're good with that. So we're gonna reset the alarm, test alarm, very simply like that. Okay, so you can see up here, we already have one alarm active because in section, our value v1 is more than 10. If we go back to 0, that alarm is already reset automatically by our function. If we go more, it'll be activated again. So now in the alarms list, we'll see that this alarm is active. And we have a list of messages that says value it's more than 10. Now it's currently active. Here it lasted 12 seconds, and when they were actually activated. Okay, then we can set an alarm with delay. Very similar as write val delay. We can just write set alarm delay, name of the alarm, the message, value more than 10. And then we want to give it a delay of 2000 milliseconds. Okay, we save it and upload it. Now if we go back to function and let's say we put this to 0, everything gets reset, everything's fine. We go more than 10. It's going to wait 2 seconds this time, and after 2 seconds, that alarm gets activated. So there might be situations where a value goes over a certain limit. You want to wait a little bit to send an alarm out. You can just wait a certain amount of milliseconds now, and then if that persists for more than that time, you can then activate your alarm. Alarm active, it's a function that returns whether an alarm is currently activated or not. So here we can just debug message that and say alarm is and here we write test alarm. So this now will print the status of that alarm. Currently is 0, so there's no alarm active. Go to section and go over 10. It became 1 because this alarm is active. So very useful just in case you want to check if any alarm is being activated because of a certain situation, then you can act on it and, for example, turn off a motor or something like that. And then the last one is any alarm active. This takes no argument, and it's just a quick but very useful function that will let you know if any alarm in the system is being activated whatsoever. So as the last one, we have a separate APIs. We're not going to go through this APIs list yet. It's kind of an experimental feature. So if you guys want to experiment with it, please go to the documentation. We don't suggest using this feature just yet as of July 2021, but we'll keep you posted on that. All right, here's a quick function to show you how the system works a little bit, and we're going to use some of the function blocks we saw before to demonstrate on this little board what we can do with just a couple of lines of code. So this first block will blink the LED strip if the yellow button is pressed after 3 seconds. And while we do that, if the selector is on 0, we're going to blink blue. If selector goes to 1, we're going to blink green. So if we go through the function, it says if the value of button 2, which is this one over here, it's equal to 1, we start a timer. When the timer is over, we're going to check if selector is equal to 1, we're going to blink the green one and keep the blue one off. Otherwise, we're going to blink the blue one and keep the green off. If the whole thing is off, so if the button, then when you release the button, then we're just going to reset the timer and write the value of green to 0 and blue to 0. 2, 3. right? Now the blue is blinking. If we switch the select to 1, the green will be blinking. If we let it go, everything shuts off. Okay, and the second little function is we have an indicator voltage here, this voltmeter, sorry, this volt generator, and we've wrote a little function. This is slightly different than what we've shown so far. So first of all, in PHP, variables, so variables that you can use inside, they can be declared just by putting $ and then a name. Now, we don't suggest necessarily to use this if you're not too much expert, but we can declare any variable, be like var1 equals to 1. So now this, if we copy this and we use it, this will have the value of 1. So what we did here, we assigned the volt, we did read value of the volt gen, which is this little guy right here. We assigned it to a variable called v. And then we created an array, which is the same thing as it's regular variables, but it's a combination of them. So there's a set of array of values. If we go through this code, it says if v, so our voltage gen value, this one right here, and now it's 5.4. If it's more than 0, we're going to assign to the first piece of this array the value 1. If it's more than 2, we're going to assign it to the second piece, value 1, and so on until it's more than 8. We're going to assign it to the fifth piece. So all these will become 1. And then at the end, we're writing values. So simply light 1, which is this one over here, we set it exactly to the value of lights array at position 0. And then lights array position 2, 3, 4, and 5. So 0, 1, 2, 3, and 4. So if I change the value of this little volt generator, if we go lower than 4, you'll see the lights turn off. Lower than 2, second turn off. And that one will always stay on because it's just less than 2. And then we can go all the way up to more than 8. And the fifth will turn on. Now, we have set also another function here, which is our safety function. And you see that this red LED strip turn on. That's because we said that if the volt gen, it's more than 8, we set it on with a delay of 2000 milliseconds. This voltage is too high. And then otherwise, if we go lower than that, then we can use button 1 to reset that alarm. So as you can see, we went more than 8. So in the alarms list, we have a voltage alarm that says voltage is too high, and it's currently active. Now, if we go lower than 8, the alarm stays active because in our function, we said that if it's not more than 8, then whenever we pressed the green button, which is button 1, we're going to reset that. So let's do that. So that reset the alarm and it's now gone. Now we put another little safety thing, which is we want to say that whenever this proxy is detects something, we want to make sure that all the LED strips are off. So for example, let's try to turn it on from before. It's now blinking. Whenever we touch this, an alarm gets activated. We turn on that LED light, and an alarm is now active here. Now, whenever this is released, so whenever proxy is not equal to 1, we're gonna reset that alarm. So I'll let it go. That alarm is reset. It's all good. Now this red LED strip is turning on because we have a set variable system alarm to 1 if any alarm is active. So we're setting an actual variable in section system alarm, and then we're assigning that value to the red LED strip. And so this is our little test board. Hope you enjoyed it. Please let me know in the comment if you have any questions. Functions blocks are pretty simple at the same time, then it's all up to you. You can create very complex automation systems just by using a combination of these ones all together. All right. If you have any comments or questions, please send it to automation@bioforcetech.com. Thank you.